NXP Solutions NFC Reader Design. We define an NFC reader as a powered device capable of generating an RF field and starting a communication with a smart card, NFC tag, an NFC phone, or other NFC-enabled device. The architecture of an NFC reader is pretty standard. It consists of an antenna, a matching circuit, the NFC IC, the host controller, and, optionally, a contact reader and a SAM module. The NFC reader IC is the RF transceiver enabling the contactless communication and supporting the three operating modes: read-write, peer-to-peer, and card emulation. This chip is in charge of dealing the signal modulation and handling the data transmission through the RF interface. We should select the appropriate NFC reader IC considering the application requirements. Among others, we need to take into consideration aspects such as the RF protocols supported, single or multi-protocol reader, the NFC operation and communication modes, the RF performance, especially for NFC forum and EMV co-compliancy, the host interfaces, or the power requirements. The host controller contains the embedded firmware and manages the NFC reader IC according to the application logic. To identify the appropriate host controller, we need to consider our application requirements in terms of memory resources, clock frequency, MCU architecture, host interfaces, power consumption, GPIOs, and other peripherals. Typically, microcontrollers are not designed to store the secret crypto keys for an application, and therefore they don't offer reliable protection and security mechanisms. For that reason, the use of a Secure Application Module, SAM, is recommended for contactless transactions that require a higher level of security and need to deal with cryptography. The SAM is a tamper-resistant chip providing features for secure cryptographic key storage, optimized hardware for efficient cryptographic calculations, and secure communication with a host controller and contactless cards. As a result, by integrating a SAM module in our NFC reader design, we achieve a robust NFC reader architecture for security-sensitive applications. The NFC antenna is a conductor loop of several turns generating a magnetic field. This magnetic field is not only used for powering the card or NFC tag, but also for data exchange during the entire contactless communication. The NFC antenna and its matching circuit must be accurately designed in order to achieve an optimum RF performance and a satisfactory user experience. Generally, smaller antennas are able to provide strong magnetic field at close distance, but this magnetic field falls rapidly with distance. Bigger antennas provide smaller magnetic fields at close distance, but they have a flatter behavior. Electrically, each antenna is a resonant circuit with a specific input impedance. The specific antenna parameters depend on the antenna material, number of turns, thickness, distance between windings, etc. The antenna input impedance must be measured with a vector network analyzer. The EMC filter is a low-pass filter aimed at eliminating harmonics, reducing noise, and complying with EMC regulations. Its cutoff frequency defines the overall detuning behavior as well as the transfer function of the antenna circuit. Usually, the cutoff frequency should be far above the carrier frequency, but far below the second harmonic. For asymmetric antenna tuning, the filter cutoff frequency can go up to 22 MHz, while for symmetric antenna tuning, the filter cutoff frequency should be around 14 MHz. With the low-pass filter parameters, we need to calculate the missing matching circuit values to maximize the power transfer to the antenna coil. The ideal impedance matching conditions happen when the equivalent load seen from the NFC reader IC is purely resistive. Typically, an iterative process is required to fine-tune matching circuit components and adapt the results towards optimum performance. The design of the receiver circuit is a straightforward process and consists of a voltage divider and a coupling capacitator. The objective is to set the voltage level at the reception pins to achieve a good sensitivity without exceeding the voltage limit. In case it needs to be adjusted, the measurement of the receiver voltage must be done with a low capacitance probe so as to not interfere with the results. Find more NFC reader design resources in our NFC Technology Hub at nxp.com.